So we're going to begin with the part 6 of the IAS level Edexcel physics. So let's start. This is the start of electric circuits, by the way. We finished on waves and particle nature of light. Now we move on to electric circuits. Let's begin. Understand that electric current is the rate of flow of charged particles, and be able to use the equation I is equal to delta Q on delta T. Okay, so electric current. What is the definition of current? Sorry guys. Okay, so what's the definition of current? Current, given by the symbol I with the SI units amperes, is defined as the rate of flow of charged particles. So rate of flow of charged particles, okay? So by that definition itself, we can derive that current I is equal to delta charge, which is Q, over the delta time, which is T, okay? That's what we gain from there. So this is the equation for that, for current. You can also switch it out, keep maneuvering it. You get delta Q is equals to I delta T, and delta T is equals to delta Q on I, okay? So that's how you use that formula. Understand how to use the equation V is equals to W on Q. What is V? V is potential difference. The symbol for potential difference is V, and the quantities is volts, the SI units. Potential difference is defined as the energy transferred, per unit charge. So by that, between 2 points in the circuit, okay? Between point A and point B, okay? So how do we define that? You have a circuit here. There's like a battery and stuff here, okay? I haven't drawn that correctly. Let's say you have a circuit here, okay? You have a switch here, and you have this. When this switch here is closed, from point A to point B, the amount of energy transferred from this point to this point per unit of charge also transferred from this point to this point is defined as potential difference. So PDV is potential difference, which is given by V, is defined as the energy, which is the work, per unit of charge Q. That's your formula there, okay? Yes. Understand that resistance is defined as R is equals to V on I, and that Ohm's law is a special case when I is proportional to V for a constant temperature, okay? Yeah. So what is resistance? Resistance, which is given by the symbol of R, and the quantity, the SI unit is ohms, okay? That's the symbol for ohms. Resistance is a measure of how difficult it is for charge carriers to pass through a component, okay? So charge carriers, as they pass through a wire, resistance is what opposes that charge, and it pushes that charge back, it slows it down. So resistance is the measure of how difficult it is for charge carriers to pass through a component. Resistance is measured by dividing potential difference V over the current, or the current flowing through it. You'll note this from the equation V is equal to IR, so R is equal to V on I. Okay, that's the equation there. And that Ohm's law is a special case when temperature is constant. Okay, Ohm's law. What is Ohm's law? Ohm's law. Ohm's law states that for an ohmic conductor, current is directly proportional. I is directly proportional to the potential difference that across it, given that T is given T is constant. Okay, that's what you have to know there. If the temperature is not constant, then Ohm's law for an ohmic conductor does not apply. So Ohm's law only applies when T is constant, okay? Understand how the distribution of current in a circuit is a consequence of charge conservation, and understand how the distribution of potential difference in a circuit is a consequence of energy conservation. Okay, so charge conservation. What does charge conservation state? It's over here, actually. Yeah, so charge conservation. What does charge conservation state? It says that the principle of charge conservation states that the total electric charge in a closed system does not change. Okay? So what do you mean by this? If you have a typical circuit here, okay? The charge in this circuit, since it's a closed system, there is no open loops, it will not change. It'll be completely constant, okay? These are given by Kirchhoff's laws, okay? So Kirchhoff laws. So Kirchhoff has two laws. The first Kirchhoff's law states that the current flowing into a junction is equal to the current flowing outside the junction. What do we mean by this? Say this was an extended version. There were 3 resistors instead of 1. Over here, the total current, which is here, let me zoom out a bit, the total current I total will be equal to I1 plus I2 plus I3. Okay, so the total current flowing into a junction is equals to the total current flowing out of that junction. This is equal to IT. This is I1, I2, I3. So charge or current is not lost, okay, in this situation. That's what we have to know there. For this reason, in a series circuit, so let me just draw a series circuit real quick. In a series circuit, current does not split up as it follows one series or one path. So current in all 3 resistors will be the same, but in a parallel circuit like this, the current will be changing in the resistors as it does split, okay? That's what we have to know for that, okay? Yes, so there's also another term we learned here, energy conservation. What does energy conservation state? Energy conservation, the principle of conservation of energy states that energy cannot be created nor destroyed, but it is transferred from one form to another. So if you have a certain amount of energy, 5 joules, that energy will be converted to different forms of energy, but it will never be destroyed, okay? It will just be transferred. Okay? So next part. Wait, not next part. Let's get more deep into that, okay? This is where Kirchhoff's second law comes into place. So first law, this is the first law, that current I T is equals to I T after the junction. So current flowing into the junction is equal to the current flowing out of the junction. And Kirchhoff's second law, Kirchhoff's second law states that the sum of all voltages in a series circuit is equals to the battery voltage, or the sum of all voltages in a loop is 0, okay? What do we mean by this? What we mean by this is when you have a circuit in series like above, okay? Let me just draw it again here. The potential difference of the battery is a sum of the potential difference of each of the 3 resistors in series. That's what we have to know there. So Kirchhoff's second law states that the sum of all voltages in a series circuit is equals to the battery voltage. Okay, that's what we have to know. So V battery, V1, V2, V3. So V battery is equals to V1 plus V2 plus V3. But in a parallel circuit, however, okay, the PD is shared across. In a parallel circuit, there are many loops that form. Let me just draw that here for you. So this is a parallel circuit, and as we can see, there are many loops. What do you mean by this? Let me just demonstrate what the loops mean. This is one loop, this is the second loop, and this is the third loop. Okay? That's what we mean by many loops. So V battery, V1, V2, V3, the potential difference at the resistors is V1, V2, V3. The potential difference of the battery is V battery, okay? So VB is equals to V1 plus which is also equal to V2, which is equals to V3. Keep in mind, these apply if the resistors have the same resistance, okay? All of these laws, Kirchhoff's first law and Kirchhoff's second law. No, not Kirchhoff's first law, it can be changed up. These resistors can have different resistances, but the current flowing into the junction will be equal to the current flowing outside the junction, okay? So that's it for the Kirchhoff's laws. Yes. Be able to derive equations for combining resistance in series and parallel using principle of charge and energy conservation. Be able to use these equations. Okay, so let's begin with what we mean by these terms, okay? Let's look at, we're drawing this again, okay? We have a circuit in series. Yes, the battery will have a PD of V. The resistance of resistors will be R1, R2, and R3. Okay? Now, the current flowing through each of these resistors will be the same because it is one closed loop. So current flowing will be the same. Okay? So to find the voltages across these resistors will be V is equals to IR. I is the same, so let's just add that up. So for resistor 1, it will be I total, which is the total current, times R1. For R2, it's going to be I total again, plus times R2, this other PDs. And for R3, it's going to be I total R3, okay? And what is this equal to? Energy of conservation in a closed loop, sum of potential difference is equal to the potential difference of the battery. So V is the potential difference of the battery, and it's a sum of all the rest. So we get this equation, okay? Now, what is the, okay, so we have this. I total is the same in all three, so we can factorize it out. I total, so R1 plus R2 plus R3. And we can divide both sides by I to get R. So R is equals to V over I. So when we divide both sides by I, T, it cancels, and we get R total is equals to R1 plus R2 plus R3. They might ask you in the exam to derive this equation, and this is the exact way in how you do it, okay? Now this is the other side of the debate. You have a circuit that is in parallel, and you're told to derive the equation for the total resistance. What do we do here now, okay? For this, we have been told that the current that enters the loop, I total, is equals to the current that exits the loop, I total, and that the current splits up, so I1, I2, and I3. Okay? So we've been told those things. So, what do we write here, okay? I total is equals to I1 plus I2 plus I3. And these I's, remember, the voltage of the battery in parallel is equals to voltage across all the loops. So the voltage is all the same, okay? And current I is equals to V over R. So V is equal to IR, the normal current equation. Make subject formula of I, you get V over R, okay? This resistance R1, R2, and R3. So let's just substitute. I1 will be equal to V over R. So V over R1 plus V over R2 plus V over R3. The voltages across all the loops is the same, okay, as the battery. So we get this. Now, again, we will simply substitute. We will factorize V because it's common in all three equations, okay? So let's just factor it out. So V 1 over R1 plus 1 over R2 plus 1 over R3, okay? And we will divide both sides by the I, okay? By V, by V. V cancels. You are left with this. Now what is this equal to? We do know that V is equals to IR and R is equals to V over I. But this is I over V. So we will do 1 over R is equals to I over V. And hence this is equals to 1 over R. So 1 over your R total will be equal to 1 over R1 plus 1 over R2 plus 1 over R3. That's how you derive that equation, okay? It's very lengthy, but you have to know how to derive those equations. Yes, so in the next video we will be completing the rest of these topics.